Welcome to CSCI 150. You should have received a link to Canvas in your email by now, and this is where we'll be posting all of the course materials and where grades will be assigned and feedback given. So once you reach the CSCI 150 Canvas homepage, it should bring you to this homepage. It should look something a little bit like this. There'll be a course overview and then the introductory unit. And I want to take a look today at the syllabus, which you can access if you click on it, or it'll pop up right inside of Canvas for you. Okay. And so this is an online class. We don't actually ever meet together in this course. If you need to reach me, you can reach me via email, ehill1@drew.edu or em as in Mary Hill @drew.edu. Or you can make an appointment with me and come by my office, or you can make a virtual appointment, and I'll talk about that in a little bit. You can also call my phone number. However, unless I'm in my office, I'm unlikely to get your call. The best way to reach me is via email or using one of the other communication mechanisms that I'll discuss below. Because of the nature of the course and that it's online, my office hours are by appointment. I can be available almost any weekday, Monday through Friday, typically at 10 to 5. I can also make appointments outside of that on certain occasions. However, I try not to make a regular habit of that. In this class, we're going to learn about how do we automatically solve problems using computers. And by the end of the course, you should be able to implement basic solutions to solve computational problems, especially our final project will be gaining insight from some kind of a data set, whether it's textual information or numeric, but you'll be using programming to analyze some sort of data. We'll be learning Python, which is a very popular and easy to use programming language, and use it to implement our algorithms. So what are the requirements for the materials and the technology that you need in this course? It's an online course, so you will have to have a computer. That's always a requirement in this course. And I recommend a Mac or Windows desktop or laptop computer. I also believe a Surface may work. I've seen students use it in the past. What probably won't work is a Chromebook unless you are significantly familiar with Linux or a Unix working environment. If you don't know what those things are, then please don't use a Chromebook for this course. The software won't be able to run on it. We will be making use of a number of different software platforms and websites to communicate content and coordinate our activities in this course. So Canvas, which I just showed you, this is the home base. Everything gets linked from here and all of your grades will be posted here. However, it's not the best solution for communication and discussions. And so for that, we're going to be using Slack. This is a professional development environment used by software developers all over the world to coordinate their work, as well as other project management or project groups. And so we're going to be making use of that. And so during each learning module, I'll be asking you to contribute to discussions, whether asking questions on anything you understand, as well as posting responses when you do understand something. I will be posting all of my materials that are linked on Canvas to Google Drive. You usually won't need to access Google Drive directly, but if you find it's an easier way to navigate the materials, it's there as well. We'll be holding virtual meetings using a software package called Zoom. We will also be piloting some tutoring hours, some virtual tutoring hours, and more information about that will be forthcoming. The first assignment I'm asking you to perform is an exploration of computer science and telling things what to do with code.org. And then after that, later this week, we'll be looking into installing Python 3 on all of our computers, as well as PyCharm, the community edition. And those are the platforms and the tools we'll be using to develop our programs. Now, the textbook I have recommended here is not required. It's also free. So there's no risk to you to perusing it or downloading it in PDF or HTML form. I will be including many materials, reference materials for you throughout this course. However, some students find it useful to have a textbook to refer back to. And so I highly recommend this text. Now, assessment. How will we be going about learning what it is that we're learning in this class? It's an online class. And what's different about an online class is that we're actually a virtual learning community rather than a face-to-face learning community. And that changes the nature of our interactions. Whereas in a face-to-face class, I can hand out a sheet of paper and have students spuriously start working in groups. We don't have that same kind of convenience because we're not all synchronously in the same place at the same time during this class. So participation and engagement becomes a much more significant challenge and something we really have to focus on investing in. The goal is not for you to work on this material alone in your own little bubble. The goal is that we're developing a community of learners devoted to learning computer science and specifically Python in the next 5 weeks. And so while the time commitment is flexible, participation is really, really important. And so you'll see that's worth 20% of your grade. So we're trying to really build a community of learners and not just have 10 individuals learning this material on their own. And so that's part of this process. There will be a number of learning exercises and exercises that actually don't count towards your grade but are necessary for learning. And so that's also a way you can engage with the course. In addition, with the virtual tutoring hours, we will have additional practice exercises from the tutors that are worth extra credit that you can only get from the tutors themselves. And I'll have more information about that later on in the week. There will be some homeworks because like any skill, learning to program takes constant practice. Late submissions will be penalized about 25%, so you'll get 75% credit if your homework is late. Quizzes are also worth 10%. We will have a number of quizzes throughout the course, usually at the end of each 1 or 2 learning modules. We'll have a final project where we apply our newly developed coding skills with an open-ended project of your choosing. And finally, we'll have 2 exams, a midterm and a final. If you're interested in the dates of those exams, they're on the Canvas calendar, and I'll show you that in a moment. In this course, obviously, you'll be using technology, and you'll be using a computer to work through the examples and practice coding on the assignments. In this course, we're going to focus on developing 2 critical skills with regard to programming: reading code and writing code. Just as a writer who writes novels gets good at writing in part by looking at what other people have done and looking at other works, other books, programmers also have to learn how to read other people's code. And it becomes a really critical tool to your learning, not just for this course, but for learning to be a computer scientist and an independent programmer in your own right. So my recommendation is when you come across a reading example, if I ask you to read some code, please try to walk through it without typing in the code or running the code. I know it may be difficult at first to resist the temptation just to run the code. And your computer is in front of you the whole time during this online class. It would be very, very simple just to sit there and run the code examples that I give you. Please resist that urge. You get to run them, but pause and wait a moment first and read through them and try to predict what the output will be. This is how we can learn computer science really efficiently and effectively. When you make an intuition about what code does and then you run it, you only need to correct your understanding of the places where the output didn't agree with your intuition. And so it helps you really focus and target your learning to just what you need to learn and focus on. And so it becomes a very personalized process. But to take advantage of that, you have to resist the urge to just run the program and to actually take that moment and write down for yourself what you think will happen when that code is executed. It's also an important path to understanding so that you can write code effectively in the future and becomes a basis that we can build on in future computer science courses. Academic honesty becomes even more paramount in an online course. Normally in a face-to-face class, my students would take their exams without access to a computer. So I'm trusting in you that when I ask you to read code on an exam or a quiz that you are not typing that code in. I will make it slightly more challenging by giving you pictures of the code and possibly enforcing a time limit. But it's really up to you to decide, are you going to earn and deserve the grade that you are given? If for some reason you need academic accommodations, please don't hesitate to reach out. Now back to the Canvas website for the course. There is a calendar for Canvas, and this is a great way to get a sense of where things are in the course and when things are happening. All of the materials that you'll need for the following day will always be posted by the night before, hopefully many nights before, but this is the beginning of the course, and so we're just getting started. We have the first quiz later this week. We have a midterm next week, and the week after that, we have the final exam by August 10th. And so those are some guideposts to help lead you on your way. I'll be rapidly posting the other assignments and materials as the week progresses.